Final video, this is video 5. We're going to graph this logarithmic function. So, ladies and gentlemen, the trick to graphing logarithmic functions, see, it's very difficult. Well, actually, let's start by always identifying h and k. So, h is -1, which means you're going to go 1 to the left, and k is -2, which means you're going to go 2 down. So if you have a problem with graphing, you always start with identifying h and k, and then after that, you kind of, in a sense, ignore h and k. So I'm going to ignore h and k, and I really want to graph the logarithmic function log base 2 of x. Now the problem is, when I try to come up with some coordinates for log base 2 of x, that becomes very difficult to do. It's a lot easier to find the coordinates of the inverse of log base 2 of x. Okay? So what am I talking about, the inverse of log base 2 of x? It's kind of like if we covered up log, right? It's kind of like if we covered up log. What kind of equation does that look like? It looks like y equals 2 to the x power. So if we find the coordinates to y equals 2 to the x power, and we know that y equals 2 to the x power is the inverse of this guy, then all I got to do is switch my coordinates. So once again, I'm covering up log, so it looks like 2 to the x power, okay? So right here we have y equals 2 to the x power. Let's find the coordinates to y equals 2 to the x power, x and y values. And we're going to use consecutive integer inputs. So all you have to do is plug in one easy input like 0. When you plug in 0 right there, 2 to the 0 power is 1. So that's your output. For the input 0, you get the output 1. Now at this point, since it's an exponential growth function, you could actually make your output grow by the base, which is 2. So if you look at your base or your output 1 and you want to make it grow by 2, 1 times 2 is 2. And then times 2 is 4, and times 2 is 8. So that's how it grows. Going in the opposite direction, if it's growing by 2 this way, then it's getting cut in half this way. In other words, multiplied by half. So 1 times half is 1/2. 1/2 times half is 1/4. And 1/4 times half is 1/8. So ladies and gentlemen, we have the coordinates to the exponential growth function. But we know that we don't have an exponential growth function. We have a logarithmic function. I can move this box now out of the way. And the logarithmic function is going to have the same exact coordinates, just it's an inverse, which means you're going to switch them. So these coordinates over here will be the same exact coordinates over here, but the x's and the y's are going to be switched. So instead of -3 and 1/8, it's going to be 1/8 and -3. Instead of -2 and 1/4, it's going to be 1/4 and -2. Instead of -1 and 1/2, it's going to be 1/2 and -1. And so on and so on. So all I've done is taken the exponential growth coordinates and switched them all. The 3,8 became 8,3. The 2,4 became 4,2. So now I truly have, I don't even need these anymore. Now I truly have the coordinates to my log base 2 of x function. But notice that it doesn't have the h or k shift. So I'm going to graph them, then I'm going to move them according to h and k. So let me graph them. You're going to have 1/8 and -3. So 1/8 and -3, 1/8 from the origin is hardly anything. Look, here's 1/8 right there. And -3, it's going to be way down here, super close to the y-axis. Okay, and then the next coordinate is what? Somebody read it to me. 1/4 and what? And -2. So 1/4, it's a little bit more than 1/8. It's kind of like halfway to the halfway point. And -2 is going to be down here. And then the next one's going to be 1/2 and -1. And the next one's going to be 1 and 0, correct? And the next one's going to be what? 2 and 1. And the next one? 4 and 2, and then 8 and 3. So the last one, 8 and 3, it's already off the graph, but we could put it out here anyway. So as we could see, it infinitely approaches the y-axis. So you could draw your asymptote like if it's actually touching, even though you know it never really touches, it just infinitely approaches. Now, these coordinates are not the final coordinates. I still need to shift them according to h and k. So my h is 1 unit to the left, and my k is 2 units down. So I'm going to start with my asymptote, and I'm going to move that asymptote 1 unit to the left and 2 units down. So my arrow is still going to be over here, but it's just 1 unit to the left. All of these coordinates are going to move 1 unit to the left and 2 units down. 1 unit to the left and 2 units down, and so on and so on. Okay? So let's go with blue dots. If I take this first dot up here and go 1 unit to the left and 2 units down, I'll be right on the x-axis. If I take this next one, 1 unit to the left and 2 units down, I'll be at 1, -1. If I take the 0, 1, or 1, 0 coordinate and 1 to the left and 2 units down, I'll be right there. And so on and so on. So we know that it infinitely approaches that asymptote, so it curves, and there's your graph. And that's how we graph. Not only that, we need to understand the asymptote. What do I mean by that? It infinitely approaches a certain line. It infinitely approaches that line right there. So you're going to need that to state the domain and range. So the domain is talking about the x values. So let's talk about domain here. Domain, or we're talking about x. Does this really go to the left forever and to the right forever? No. So it's not all real numbers, right? Notice, look at this graph, guys. It infinitely approaches this line and never passes this line. It infinitely approaches this line. And it does go to the right forever. So it's all from here that way. So how would you represent that as a domain? The x has to be what? Greater than? -1. -1. And you can't even say greater than or equal to because it never actually touches. It just infinitely approaches. And now how about the range? The range are your y values. Now, if you look at the y values, does this blue graph go down forever? Yes. Does it go up forever, even though it curves? Yes. So what do we say about the range? All real numbers. Ladies and gentlemen, we're going to have one of these exact questions on the test. So make sure you understand how to do this. Good luck.